Good morning, everyone. We're going to get started in just 1 minute. Hope everyone is happy on this hump day morning. All right. Well, thank you, Laura, for looking after the presentation slides. Since I can't seem to download anything today, I'm going to be turning off my video, but I wanted to introduce myself first. Thank you for joining us for another in the Lightline webinar series. Today, we're going to be discussing mixing and matching drivers to select the right output for the job. My name is Eric Teacher. I'm the National Specification Manager here at Lightline, and I support our Canadian agent base, but I'm always happy to take calls from US friends as well. So we'll review a couple of basic terms first, since we're going to be talking about illuminance levels and getting the right light for the job. It's important for us to understand some of the key terms. So illuminance is the measurement that we take to understand how much light or how much flux is going to hit the work plane. The work plane can be the floor or it can be a desk, and we'll talk about that in a bit further. To understand the reading or the metric that you're get when you measure illuminance, we have to review the foot candle and lux. So the foot candle is a measurement that we use when simulating or measuring the lighting requirements for a space. And those requirements those guidelines have been set out by a number of global organizations, one that is North American based that we'll talk about a little deeper. The higher the illuminance level, the better your visibility is going to be. So we talk about the foot candle as a metric, as a unit of measurement, and a foot candle is defined as a 1 lumen per square foot. And looking at the illustration on the bottom right, we can also extrapolate that to a metric measurement, which is 1 lux, and 1 lux per square meter is equivalent to 1 foot candle per square foot. In fact, the corresponding conversion is rounded up to 10.8 lux for every foot candle. So make sure you're interpreting the requirements based on metric or imperial measures. Next slide, please, Laura. There are additional factors to understand when lighting a space and understanding how to get the optimal light output. One of those important metrics today is color rendering index. So this is our ability to see the reflected light that is produced by the source. And in this case, we're talking about the color rendering index. Short is CRI. CRI is essentially a relative measurement that is subjective. It's interpreted by people in a room with a variety of lighting environments, with sources that have different CRI and 16 different color palettes used. One subjectively attributes a number from 0 to 100 for each of those color palettes, and at the end we get a reading in the 0 to 100 range, 100 being ideal or perfect. If we refer to the natural light source, our sun, as the perfect light source that renders all colors well and evenly, we begin to understand why it's important to have a metric for artificial or electric light sources. Next slide, please, Laura. Another important element to understand is correlated color temperature, otherwise known as CCT. The CCT will influence the mood of your space. In warmer color tones, you'll feel relaxed, and in higher or cooler color tones, you'll feel invigorated. And there are specific psychological research studies that have determined that CCT can influence our behaviors in a space, which is why back in the 60s and 70s, when fluorescent lighting systems were first coming into the marketplace, school boards chose the higher CCTs in the 4100 Kelvin range, known then as cool white, to invigorate the students or to keep them alert. So that's another metric. Now, CCT will influence the output of a light source, but not as significantly as CRI. The higher your CRI, so the better the light quality, which will give you better fidelity and saturation, the lower your luminous efficacy. So a source that is able to produce 1,000 lumens at 80 CRI, which is perfectly acceptable, by the way, will only produce roughly 600 or 660 lumens at a 90 CRI. And of course, that changes from form factor to form factor. So a track head and a downlight will have different differentials or trade-offs in terms of color performance, color rendering, and electrical efficiency or efficacy. Next slide, please. So there are some additional factors to understanding how lighting influences the space, or how lighting is influenced by the space when we do lighting design. And so a few more of those are illustrated here. Reflectances obviously have a very significant impact because as the light bounces off the various surfaces, brighter surfaces will reflect more light, whereas darker surfaces will not. So in a dark surface, you need more installed lumens in order to achieve the same illuminance or the same lighting conditions. The finish will also influence how the light disperses, reflects, or interacts in the space. So things like brick and stucco that are highly textured will reflect much less light. Light will get scattered into many different directions than smooth, glossy, or specular surfaces, such as standard, white eggshell walls. They will have a reflectance typically in the 50 to 80% range, depending on the color of the paint and the pigments. Space utilization is an extremely important aspect when considering how much light you need, because this now relates to our ability to see fine detail or perform fine motor tasks. So a watchmaker may need a lot more light than someone who is moving materials from one space to another. Just as a surgical suite will have significantly more light than an office space for reasons that have to do with the task. Occupant age is a really important element that many non-lighting designers tend to forget about, and that is because we've got an optical receptor that degrades over time. So the human eye at the age of roughly 20 needs a factor of 1 to be able to see well. By the time you are at 40, you need a factor of 2. At 60, you need to double your light output again to see just as well or as acutely as you saw in your 20s. And that continues to go up in requirement as the eye ages. So if you're doing any kind of work in retirement homes, nursing homes, residences where seniors are gathering or congregating, consider the lighting requirements for that aging eye. The work plane is the last piece that we have to consider in terms of where our target lighting needs to be derived. So in the illustration at the right, this is a kitchen. So our work plane happens to be the island, the sink, the countertops, the stove, etc. Whereas if we were moving through a corridor, the work plane would actually be the floor, because that is our transition space. Just as in an office, the desk is your work plane, whereas in an atrium lobby, the floor once again becomes your work plane. Next slide, please, Lauren. So there's a whole raft of bodies, associations that profess to provide guidance in terms of recommended light levels for physical applications. The IES, the Illuminating Engineering Society of North America, now just known as the IES, is the body that publishes the most extensive range of foot candle recommendations, or recommendations for lighting every type of space. Apologies for the reading chart. It wasn't really meant for you to read the IS foot candle recommendations. This is just a table that's widely available. And it is derived from the IES 10th edition handbook, which is a little over 1,000 pages, actually a little under 1,100 pages. So for anyone that wants to do a little more reading on the subject, there's plenty of reference material out there. Next slide, please. We've taken a few excerpts just to highlight some of the light level recommendations or target illuminance levels that we would be working to achieve as lighting designers or as design build opportunities come up. So this is an example of a hotel, and in hotels there are different spaces that require different ranges of light levels for accurate perception of the tasks and the spaces. So you can see that in a lobby and general lighting applications, you only need 10 to 20 foot candles, otherwise referred to as 100 to 200 lux. For a reading area or working areas, you're going to want to increase those light levels. And you'll notice in the linen rooms where they might do some sewing, they are looking for light levels between 100 and 200 foot candles. That's the same light level that you would want to achieve on an NHL ice rink. So very high levels for doing very, very fine tasks that require critical visual acuity. Next slide, please. Offices, equally diverse in their lighting requirements. You could generally say that most office spaces can be adequately lit with between 35 and 50 foot candles. But these stipulations, these guidelines and recommendations are meant for the median age group in the 40 to 60 range, and that means that our light levels are slightly higher than you might anticipate. Now, looking down at the reception area, would we ever light a reception area to 0 foot candles? Well, artificial light sources maybe if that reception area was completely awash with daylight. But what happens at 4 o'clock in the northern hemisphere during the winter? So never a good idea to accept 0 as a recommended guideline. In this case, a reception area you would light almost as well as you would light the office, because the receptionist, the person sitting at that desk, has visual tasks to perform. Next slide, please. All right, so now we get into the meat and potatoes of today's talk, and that is the ability to change or select the correct lumen output or an appropriate lumen output for your project or your conditions. And here is where we introduce you to, oops, that is supposed to read UL 2108, not UL 2018. UL 2108 is a standard. It's a low voltage standard that allows us to mix and match our low voltage products, so our Slim, Slim Pro, and Luna series products with standard and commercial drivers. So just as the Luna today is shipped with a 12-watt driver, we will show you how you can take that Luna, and if it's not producing, or if it's producing too much light rather, we can actually step it down. While we talk about the commercial drivers that are UL 2108 approved, I'll also talk a little bit about being able to tune or get the right output from some of our other products, namely the Edge series troffer, which is redefining troffers, the Forum LED panels, and the Forum Linear series, which is a new 6-inch by 2 foot, 4 foot, and 6 foot product that looks like a panel but installs to appear just like a linear slot light. Next slide, please. So the driver, while this is illustrating the commercial driver, our standard driver looks a little bit different. It's a blue box in typical Lightline fashion. A lot of what we do, we use Lightline blue, and so when you see that blue box, it's your assurance of quality and superior performance. But just to talk about the commercial drivers that we can offer for our Luna series and Slim Pro, we can mix and match for different voltages, for different types of control options. And of course, we can remote these drivers. We're going to be looking at a table very shortly that shows the standard outputs versus what we can achieve by mixing and matching our drivers, which are UL 2108 approved. Next slide, please. So here's a little table that we put together to illustrate a couple of our product series and their standard outputs. So we'll start with the Luna 4, the RA4. We have 12RG, we have a variety of different form factors, and we typically drive this classic Luna style with the TIR lens at 12 watts or at a specific millicurrent that consumes 12 watts, and we are able to produce 1050 lumens that will be delivered to the work plane. Now, if that is too much light and we don't have a dimming option available because the homeowner doesn't want to incur the expense of dimmers, or because the application simply doesn't have a neutral and an appropriate dimmer wouldn't work, here we can mix and match with a 9-watt driver to actually reduce the output and shift the entire output to a maximum of 800 lumens. If we look at the Luna below that, this is our newest designer series, Luna 4. The typical light output at 3500 Kelvin is 900 lumens at 12 watts. And again, we can reduce the output if we needed to cap it at 700 watts just by mixing and matching with a lower output driver. This ability to mix and match for optimal lumen output becomes much more enticing and much more versatile as we move to the higher power products. So the Luna 5.6, which we are going to be reintroducing as the Luna Pro series, came to the market with a 17-watt driver, and we were able to generate 1270 lumens delivered. We then said that a commercial version of this driver was available for 0 to 10 volt applications or galley dimming if that's required. And at 20 watts, if we drive the current slightly higher, we can produce 1500 lumens. We then took that to the next level and are going to be introducing the Luna Pro series, which will generate 2200 lumens delivered. And we're using the 33-watt commercial driver, which we typically use with our Slim Pro 8. Now, this will flow into a little bit of a case study, which will show you an example of how this was recently used. But looking at the Slim Pro 8, you can see that our standard driver is supplied at 33 watts, and we can deliver 3130 lumens. However, we had a situation where we needed much lower lumen output, and dimming wasn't an option because we were replacing traditional technology. Just back up one sec, Laura. Thanks. So this just illustrates that at 20 watts we can reduce the top top end output to 2200 lumens, at 17 watts to 800, and at 12 watts to 1400. And now we can move to that. Excuse me. So the City of Ottawa came to one of our distributors recently with an opportunity to retrofit some 18-watt CFL pot lights. There was a shallow plenum, so consideration had to be given to the form factor of the downlight that would replace those. The objective was to find something that would fill the existing cut hole with similar lumen output. And the challenge, additional challenge, was that it was a shallow 8-inch downlight, which, generally speaking, an 8-inch downlight is going to produce way too much flux, and that was the case for our Slim Pro 8 as well. The size was good, the form factor was okay, but the wattage was way too high, and there was no opportunity to dim. So just back up to the previous slide, please, Laura. So we took the Slim Pro 8, 3500 Kelvin fixed CCT, and the 33-watt output at 3130, of course, would be obnoxiously glary with this type of a source mounted on an 8-foot ceiling. So we knocked it down to 12 watts, and look what happened. At 12 watts, we were able to generate 1,400 lumens, which is very similar to what an 18-watt CFL will produce, typically anywhere from 1,250 to 1,350 lumens. So the match was perfect. And if we needed to reduce that even further, if we were replacing a lower wattage downlight that still needed that 8-inch form factor, we could step all the way down to 9 watts and generate or produce only 1,050 lumens without needing any kind of a dimming circuit. Now, please advance. So this was an excellent example where we could utilize UL 2108, which is a certification that we have for our drivers, our standard drivers, our commercial drivers, as well as for all of the optical engines and trims. So each of the individual lunas, other than our RA3, which was the first gimbaling 3-inch Luna series downlight that Lightline introduced, we did not seek UL 2108 certification for that model because it's already operating at 7 watts, and there was no need to step that down further. Next slide, please. So now we'll just have a quick peek at some of the lumen selectable. We also have CCT selectable products, but we'll just have a closer look at the Luna 5.6 Pro. So again, I wanted to bring your attention to the fact that the standard driver is supplied at 17 watts, generates 1,250 lumens, and if we pair that with a 33-watt driver, we can generate up to 2,200 lumens. It is dimmable, and with all of the drivers, once the driver determines the maximum lumen output, you can then dim down from that point. Next slide, please. Edge is another architectural product that we can tune the output for. In this case, we are tuning the output of our Edge and panel series products with a CCT selector switch. One day, very soon, you'll be seeing news about how we plan to transition all of these products to a wireless app-based platform as opposed to a switch selector that is on the driver or on the fixture at the moment. So this will all become remote and wireless and very easy, hopefully by the end of this year. Next slide, please. Another slide on Edge. This was actually taken from a different presentation, but it illustrates how the Edge can really be installed in any application. It doesn't interfere with any of the mechanical systems and can have protrusions right through the acoustic tile in the cavity in which it's installed. Next slide, please. Here was an example of some creative use of Edge 2x2s side by side, and the reason I've added this is to show the lumens that were required. So in this case, the maximum available output was 4,200 lumens from a 2x2 foot Edge fixture, but they selected to drive it at 20 watts and generate only 2,200 lumens per fixture. And this yielded 37-foot candle luminance on the floor and 53-foot candles on the desk. Of course, the closer you are to the luminaire, the higher your light reading or your luminance reading will be. I'll show you what a little light meter looks like in a slide or two. Next slide, please. Here we are. So we talked about the work plane and where the light needs to be measured. Well, here is an example where we took a reading on the countertop. This happens to be one of the corridors at Lightline, adjacent to our cafeteria. And it's not that we put these fancy fixtures in here to make a statement, although we did. But they happen to have amazing distribution and provided beautiful light for this space very economically. And of course, the light levels are phenomenal. So you see the one on the left reading 65.3 foot candles on the counter. Probably still too much light for this particular application, but but the uniformity would be impacted if we moved the spacing of these fixtures any further apart. And on the floor, we got 35.5-foot candles, which again, you probably could live with half that in a corridor or transition space. And we'll show you how we took these measurements. A little preview of that next week. Next slide, please. Here's another unique to Lightline approach to creating higher lumen density from your fixtures. So here are a couple of applications, one of which we've already provided product for in terms of pharmaceutical application, where they needed very high light levels, 80-foot candles, and they didn't necessarily have the budget for a high lumen troffer. So here we're illustrating what we did with our edge 2x2, and instead of an acoustic tile laid into the edge, we laid a panel right on top. And so we were able to get over 9,000 lumens. These will be delivered lumens for this application out of a 2x2 grid. Next slide, please. In terms of all of these metrics and performance measurements, we do a lot of work to ensure that the data that we publish, first of all, is accurate. None of it is simulated. We use a 2-meter photometric sphere within our lab. We have a category 3 satellite ETL certified lab, which means that we do all of our testing on site, and periodically our data, our records are audited to ensure accuracy and consistency. And we also have a goniophotometer, which is a device, a piece of equipment that holds the luminaire. It's in a dark room. This is all within our laboratory space, which occupies about 8,000 square feet here in Richmond Hill. And the goniophotometer is able to provide the distribution parameters for a luminaire. So this will, the gonio tells us what the beam spread will be, what the color rendering properties are, what the luminous efficacy is, lumens per watt, our CRI, the beam details on the photometric report you see on the right. That is the first page. So you typically get a beam intensity diagram or a cone diagram that illustrates how many foot candles you'll get at a specific mounting height. It's also expressed in lux on the opposite side. The page in the middle is illustrating that we are now adding TM30 detail to all of our photometric reports. By the way, all of this information is on our website within each of the product categories. TM30 is a relatively new metric that is intended to eventually replace CRI. And so lighting designers are asking this type of data of manufacturers like ourselves, because for them, understanding the spectral power density or the nanometer wavelength distribution within that source gives them a better idea of what kind of saturation, fidelity, contrast, and general hue they're going to get from that light source. So the information is there, and we're going to be taking a deeper dive into photometric modeling next week. So I don't want to steal that thunder. The image you see on the left is actually out of a screen grab using Notepad of an IES file. So if you use the IES file, which is generated in our goniophotometer, which gives you all of this information in a 3-dimensional form factor that can be used by software to model or simulate the actual light distribution and performance in the space. But I wanted you to see that an IES file is just a bunch of data. It's all the metadata that was generated by the gonio and by the photometric sphere. So it's not readable unless you have an IES file viewer, or if you're using one of the more prominent lighting design software platforms, such as AGI, Dialux, or Visual. Next slide, please. And so next week, we're going to be taking a deep dive into using online, free online utility software, such as Visual's interior tool, to do a basic layout. And with this type of tool, I'll show you a couple of neat little tricks that give you the ability to not only determine how many lights you need for a particular space, but what type of distribution, how many foot candles you get directly below the light, and what that distribution looks like when it's rendered. A rendering, by the way, is what you see in the image that shows the floodlight or the wall wash. So rendering is a grayscale image of the lighting shades or the 3D rendered outcome. Anyways, please join us next week when we take a deeper dive using the Visual Interior tool. I'll also be showing you how to use the wall wash tool to I've got a few hacks for that. And we hope everyone's staying safe,